Well, hi there, everybody. Welcome to Dome at Home. It is really good to be back with you all. I've been saying hi to as many people as I could in the chat. It's so nice to see some familiar names and faces in the chat there, and we've got lots of folks continuing to log on and join us for finally the return of the Manitoba Museum's Planetarium and Astronomy podcast. I'm your host, Scott Young, and I've been away for a little while, but it's certainly nice to be back to be able to do this show again, because I didn't realize how much I missed it until we had stopped doing it for a while. And so anyway, now we're back. And I think that we have a new format, so we're going to be having longer but monthly shows, and I'm going to be sneaking in a few other programs in between. We've got some special events coming up that we'll get to a little bit later, and some live observing. And I do want to get, for those of you that have been around for a while, we did a star party out at Birds Hill one night. I'd like to get one of those in before the snow flies, so I'm looking for a date for that as well. Okay, well, how are you all? It's been a long time. Let me just see here. I'm just checking all the technology. No one has told me that you can't hear me, so that is really good. I have not done a podcast from this location in many months, and so if things are working, that is good. Lots of more people checking into the chat here. Nice to see you. Hey, Krishna, back from Texas, or back in Texas. Hope things are going well for you. And hi, Tracy. Oh, there's Len, Jacqueline, Anthony, Kathy. Wow, Vivian, Dale, Jay. Oh, wow. Okay, very cool. Just so many friends that we've made in this great Dome at Home community. All right. Let's do a few things. First of all, we're going to catch up a little bit on some of the things that have been happening in the sky. We're going to be focusing on the events that will happen in September, basically from now. You know, it's the 31st, so we're basically in September anyway, but all the way through to the end of September. The next show will be September the 24th. The last Thursday of the month is the format, and it'll focus on the following month. So we'll get a little bit of lead time to be able to get out and observe some of these events and things like that, which is really nice because I really quite like getting out there and observing. And to be honest, I love seeing everybody's pictures and drawings and stories and things like that after the fact. I would love to have you send in more pictures, and just like we used to do, we will feature as many of them as we can on the show. All of our links are still the same. It's Manitoba Museum on Facebook and YouTube. The email is space@manitobamuseum.ca. You can send us pictures. You can send us drawings. You can send us stories, questions, of course. If there's a question that you'd like us to explore on the show, we'd be happy to take that on and put it in a future episode. And so that's kind of where we are. Let's get back here. Wow, I really lose focus when I have to press the buttons again. I'll get better. It's okay. Cut me some slack the first night, please. Okay. What have I been doing? Well, as some of you know, my wife passed away back in February, and she was ill before that. That was not completely, but largely the reason behind Dome at Home going on hiatus. I just was not really able to commit time to it and wasn't really feeling up to things. But the family and I are doing okay, and we're getting on there. So I'm back at work doing things in the planetarium. And I've been doing quite a bit of observing. I found that, even through tough times, you can spend time under the sky, and it doesn't take it all away, but it at least lets you focus on something else for a few hours. And so I've been spending a lot of time in the backyard doing some observing. And so I'll just hit you with a couple of the highlights here. In place of the sort of viewer images that normally would go through, I'll just show you a few of the things that I've been doing. One of the things that I'm quite excited about with my new telescope that I got last year is imaging the planets. And this is an image of Saturn taken from last week. It's not great. It's not bad, but it's not as good as some of the ones you see in the magazines because Saturn just does not get very high in our sky. I'd love to take a trip down to visit you guys in Texas, actually, because from there, Saturn is way up in the sky and you get much, much better views. So that might be, for those of you that are farther south, even if you're watching from Ontario and you're in, southern Ontario, that extra 5 degrees of latitude difference really does make a difference. For us here, it just does not get high enough to get really clear views. But taking images anyway. Another thing I've been working on is imaging the sun. Now, of course, you can't just take pictures of the sun with your regular gear. You have to have special filters and special equipment. But I've been practicing with that recently because we have not one but 2 solar eclipses coming up in the next 6 or 7 months that I want to be ready for. And we'll be doing events for those. And the first eclipse is actually October 14th. So next month's show will focus on the eclipse and how to get ready for that. So I've been taking images of the sun, both with the special, what's called hydrogen alpha telescope. This one here shows basically the color of the flames on the sun. And oh, look at that. The little red logo is covering up the little flames. Right down at the bottom on the left there, you can actually see one of the flames. I think I've got a close-up view here. Let's see. Yeah, there we go. It's pretty cool to see these things. And it's amazing how much you can see with this. It's just a tiny telescope, but it's specially designed just for looking at the sun. I had it out at the Folk Fest this year. For the very first time, I went to the Winnipeg Folk Fest, not just as a patron or a performer, but also as an astronomer. And they let me bring my telescope stuff along, and we set up in the back field, sort of out of the way, between the bathrooms and the beer tent, basically. So lots of walk-by traffic. And it was great just showing people the sun. We only had one time when we got rained on, and we had a couple of days that were nice and clear and a couple of days that were kind of cloudy. But lots of folks to talk to, lots of interest. So I hope we're going to be doing that again. It really is a fun venue at any time, and it was just nice to do some astronomy there. There's a number of people in the local astronomy club that have been getting more and more into outreach, which means there's more of these sort of public telescope events starting to pop up, and hopefully we'll see more of that before the snow flies as well. I've been doing a little bit of imaging for science as well. Some of you that have heard me ramble on before know that I'm interested in looking at asteroids and variable stars and supernovas and things like that. So about half my observing time is actually spent taking relatively boring pictures and then measuring the brightnesses of things and sending them off to various international organizations. So that's kind of fun. It's nice that, you think we've got the James Webb Space Telescope, we've got, helicopters on Mars, we've got all of these things. We must know everything. There's nothing left to really do for amateurs. But the opposite is the case. The universe is just so big. There's just not enough astronomy being done to cover all of this stuff. So folks in their backyards with relatively modest equipment can actually contribute to science, and that's pretty cool. So I like doing that. Although the pictures, like I say, are not super exciting always. But I'm also trying to take some pretty pictures. This is back from February. But this was a picture that I took on a live stream. We basically just imaged and processed and created the image all in one thing, and that was kind of fun. Had a lot of folks listening in and asking questions about how to do some of the more advanced kinds of things in astronomy. And yeah, so I've been trying to do as much observing as I can, which has been pretty nice. Oops, wrong button. See? There we go. Now, if you have any questions or something went by too fast and you'd like to know what was going on, definitely just drop stuff in the chat. Lots of folks checking in there. Lots of people, have been saying, "Oh, we missed you." I missed you all as well, and I missed many of the interactions that I have with a bunch of you in between shows and things like that. It's pretty tough to miss of all those folks. So I'm glad that you're all back as well. Ulrich pointed out that my sun picture looked like a big orange. Yeah, pretty much. That sort of modeling on on the skin of the orange is actually a really good analogy for the bubbling that happens on the sun. It does look very much the same. Jennifer's asking, how big are the solar flares? Actually, maybe I'll just see if I can go back to one of those pictures here, just so that we can talk about something. Let's see. So the sun is much, much bigger than the Earth, of course. It's more than 1 million kilometers across. And so the Earth is probably about the size of that large sunspot up near the top center. And so the solar flares, the prominences, as they're called, that are sticking off the edge there, are probably about as big as the Earth. These are actually not particularly large ones. When I took the picture, there wasn't a lot of major activity going on. But all of these sort of darker, snaky lines that are all over the rest of the disk of the sun, those are basically the same kinds of activity, the same flames, except they're seen on the face of the sun. They're not just right on the edge. So as the sun rotates, some of those will actually move off the edge of the sun, and we'll see them sticking out as prominences. So lots of really big activity there. And of course, we've talked about the sun before, and solar activity has been building and building. So we're seeing a lot more sunspots, a lot more solar activity, and we're getting a lot more solar alerts that result in things like shortwave radio blackouts or things like that. And of course, the aurora, the northern lights, which are all driven by the energy of the sun. So the more solar activity, the more chance we have to see those northern lights. And there were a couple times since we were last together where there were some amazing northern light shows. I missed both of the best ones, partly because they both happened at 3 a.m. and I had given up at that point. So patience is the key for northern lights. But they have been happening more and more, and that's always a good thing for us observers. All right, so let us move on a little bit here. And I wanted to talk a little bit about the events that happened yesterday that was all over the news. And of course, the blue supermoon. This is a simulated view of the blue supermoon. It was kind of cloudy, and I have trees covering the area that was clear from my yard, so I did not actually get an image of the blue supermoon. But this is kind of what it looked like when it was up higher in the sky. Most people were quite surprised that the blue supermoon was not blue, but was actually kind of reddish orange. And it'll take a little bit to unpack that. But basically, the term blue moon is completely made up. And there's not even any good agreement on where the term came from. There are a number of ways that it's been used in the past, which are contradictory. And there are a number of ways that common usage has sort of, once in a blue moon means something quite rare. But if you use the definition of a blue moon as the second full moon of a month, well, that happens every couple of years or so, which isn't particularly rare. But way back in the 1800s, the volcano Krakatoa blew its top and showered ash all around the world, basically. And there were some actually blue-colored moons seen around the world, as well as amazingly red sunsets and all sorts of weird, colorful effects in the atmosphere, as that dust of all the different sizes basically scattered the different colors of light in very surprising and beautiful ways. I think that's where the term blue moon probably came from originally. I don't think it dates back into prehistory, but that seems to be what I think is where the origin of that is. I've never seen a blue moon, like an actually blue moon, but I've seen lots of red ones and orange ones, and particularly now with all the forest fire smoke. Forest fire smoke is smaller than a lot of the volcanic ash, and so it doesn't scatter the red light so much, it scatters the blue light, and so all that comes from the moon is the red light and the orange light, and we get that orangey red ball of fire, it looks like, when it's rising. This is actually not a supermoon. This is just a picture of a regular full moon. I do have a picture of a supermoon, though, and there it is. That's the super. Did you miss it? There we go. The supermoon is on average 8% bigger than a regular moon. One of the websites that I follow, spaceweather.com, put it in a good way. If Superman was only 8% stronger than a regular person, would we still call him super? Well, I think it depends on how good his social media manager would be, because that's pretty much where the supermoon has sort of taken off. Now, don't get me wrong. The moon is always super. I love looking at the moon, and anything that gets people out, especially people who are maybe new to astronomy, out and looking at the moon is a great idea. So I'm totally behind it. But I sometimes worry that the expectations get built up a little bit too big, and people are expecting something really giant and blue, and instead they see kind of the same moon that they would have normally seen. And so I'm worried that people will think, oh, this astronomy thing is not really a big deal, when they're missing out on the fact that the moon is always amazing. It's this other world that we can see detail on. It's only 400,000 kilometers away. It's spectacular. But anyway, I like to just go out and look at the moon anytime it's visible. And actually the full moon is nice because it's bright and it lights up the ground and can give you sort of a nice moonlit effect. But if you want to look at the moon up close in binoculars, for example, the other phases of the moon are actually a little better, because the shadows from the dark area will actually give you more of a 3D effect. The full moon, when you look at it in a telescope or binoculars, looks kind of flat without too much terrain. You mostly see these white rays that are radiating out from the craters and things like that. But the other phases are equally beautiful. So I hope everybody had a chance to see the moon. And if not, tonight will be a good night, and tomorrow will be pretty good too. The moon looks pretty full for 3 days in a row, pretty much. And unless you're really looking carefully, you probably won't notice that it's slightly out of round. And even on the night of full moon, depending on when the time was, you could actually be looking at the moon and have it be slightly before or slightly after full moon anyway. So it sort of fades in and fades out to its fullness, I guess. So that was certainly a big event, and lots of folks getting kind of excited about it, and lots of new people turning their eyes and their cameras to the sky, which is fantastic. Oops, I went ahead a little faster than I needed to. Okay, there is another full moon next month, and then the following month. And there is also in between, of course, the first quarter, the third quarter, and the new moons. The new moon is something we normally don't see because it's the opposite of the full moon. Instead of being opposite the sun, it's kind of right next to the sun or right beside it. And all we can see is the dark side of the moon, which if you're going to the Planetarium tonight for our Pink Floyd show, well, you can see the dark side of the moon. But otherwise, the dark side of the moon is invisible because it's dark. Except when things line up just right. And coming up in October, we actually have a new moon, that will be visible in the sky because it will be crossing right in front of the sun. There will be a solar eclipse on October the 14th at the new moon phase, and we'll be talking more about that at the end of the show. But it sort of fits in with the whole blue moon and super moon and all that kind of stuff, because the full moon right now is a super moon. The new moon is actually going to be, it's not really called anything, the opposite of super, micro. You know, it'll be 8% smaller because the moon is slightly farther away. And because of that, if you go to the right spot in the world and you stand in the central path of that eclipse, when the moon goes totally in front of the sun, it's not quite big enough to cover the sun. And so instead of a total solar eclipse, which is a glorious sight, you get what's called an annular solar eclipse or a ring solar eclipse. There's the sun, and the moon is in the middle of it, but it's too small, and you just get this ring of sunlight. So supermoon, the phenomenon, fits into all sorts of different kinds of things and can really affect the kinds of things that we can see in the sky, not just the moon, but all sorts of other things as well. All right, let me just check the chat here again. Lots of... Oh, James is making fun of my shirt. Okay, yes, it's funny. I decided that I needed something a little bit more a little bit less monochrome for my shirt, because otherwise it just looks like I'm this head on sort of, I don't know, a canvas lump or something like that. So I decided to wear something a little bit brighter. But let's see. Philip's asking about Russia crashing into the moon's surface. Yes, we will be talking about the recent race to the moon, and I've got some pictures and some stuff on all of that. Ulrich says there's a German movie titled 5 Days of Full Moon. Interesting. I wonder what that's about. I'll have to look into that. But yeah, I mean, pretty much, for a period of maybe 5 days, the moon is so close to full that it's very big and bright in the sky. And so anyway, I'll have to check that out. One of the things that I used to do in Dome at Home is show you the upcoming planetarium shows and do the trailers and things like that. Well, we've had a show running all summer, which is called Worlds of Ice. Those of you that are museum members probably got an invite to see it or have come down and seen it as part of your membership. But it's a really interesting show. The solar system is full of ice, and we look for ice on the moons of Saturn and the rings of Saturn, the moons of Jupiter, on Mars and in moon craters and things like that. But of course, ice is also common here on the Earth. And for the people that live in the Arctic, ice is a defining part of their lives. And unlike the cycle of day and night that we're familiar with down here, when you live north of the Arctic Circle, day and night sort of blur, because you can wind up having the midnight sun where you have weeks of daylight without any night in between. And similarly, weeks of darkness. So the sun, the regular cycle of daytime, nighttime that we have sort of incorporated into our calendar, into our way of life, really, isn't as big of a deal as some of the other things up north, particularly the ice. And so Worlds of Ice is narrated by an Inuit throat singer who Rosanna Deer, and is actually a really good show. So I want to show you the trailer for that. It's only on until September 4th, and then we switch over to our fall programming. So if you want to see it now, now's a good time. We will bring it back in the future, but probably not for a while. So if you want to check that out, here's the trailer for our latest show, Worlds of Ice.
What do you see in the ice? What exactly is ice? What makes it unique? Siku, ice, is vital for all of us. It's vulnerable, it's very old, and it comes from far, far away. Observing the ice is to get a glimpse into the future, but it also detects the echo of a distant past. Ice keeps a record of the history of Earth's climate. Where there's ice, there might be some liquid water and, potentially, inusil, life.
So Worlds of Ice showing through September 4th through the long weekend at the Manitoba Museum's Planetarium. You can see all the details on our website, manitobamuseum.ca. And members get in free to that planetarium show and all the planetarium shows as part of their membership. Okay, let's take a look at September's sky. We've got a bunch of things that will be happening in September, and I want to take a look at a few of them here. Let's get our wonderful trusty program, Stellarium. This program, again, is a free planetarium program. You can download it and set your location, and it'll basically show you everything that's going to happen in the sky forever. Really, really useful. You can print out star charts and stuff like that. Takes a little bit to get the most out of it in terms of, figuring out how it all works, but it's quite a quite a nice program. So this is the sky right now. Of course, it's not dark yet at this time, but if we just, fast forward to, I'd say by 10 o'clock, you have a pretty nice dark sky. And over in the east, we have the just past blue moon, supermoon moon coming up. And we also have the planet Saturn. It's pretty low to the sky. As the night goes on, like everything in the sky, they will, of course, rise higher up in the east, off towards the south, and then sort of get to their highest point in the south, and then start going down again. It turns out that Saturn does not get very high above the southern horizon before it starts sinking down again. It's in the southern part of the solar system, if you want to think of it that way. And so it just doesn't get very high in the sky. So we don't get as nice views. It doesn't appear quite as bright. But it's just past what's called opposition. The point when it's opposite the sun in our sky, it's basically at its closest, its biggest, its brightest, its best. But for me, and if you saw my live stream on the 27th with Saturn, you've heard this, but for me, opposition time is actually the beginning of the observing season, because that's the time when Saturn rises as the sun is setting and it's visible all night. And from that point on, it will actually rise a little earlier each day, so that by the time it gets dark, it'll actually be partway up in the sky already. And over the next month or so, it'll, be nice and high right at sunset. So you don't have to stay up super late to get a good view. You can start doing your observing in the early evening. So for me, I really like this as sort of the kickoff to Saturn. So that's what I'm going to be focusing on for the next month or so, is trying to get some nice images and do some live streams of viewing Saturn and its many moons. Saturn is currently the record holder with 146 moons. That's a lot. Jupiter and Saturn have been leapfrogging each other for the last couple of years, as one team discovers more moons around Jupiter and it's in the lead, and then Saturn gets more and it's in the lead, and now Saturn is quite comfortably in the lead with 146. I think Jupiter is still at 88, certainly well behind Saturn at this point. So that's a highlight for seeing things in the sky. The problem with Saturn, it's 1.5 billion kilometers away from us at its closest. That's just too far to be able to see the rings easily. Binoculars just won't do it unless you've got really powerful binoculars, like those big battleship ones that are sort of expensive. They can maybe bring it in, but really you need a telescope that magnifies probably around 30 times or so to get a good view of the rings of Saturn. And of course, the bigger the better. If we just zoom in here, though, Stellarium gives us the view like this. So you've got Saturn, the gas giant planet. It's all these swirly clouds and things like that that are in the atmosphere of Saturn. We think that once it might have had a solid core, but probably not so much anymore. It's pretty much hydrogen and helium all the way through. And it's surrounded by these glorious rings that are very, very thin, and they're tilted at an angle relative to us. As Saturn goes around the sun in 29.5 years, the view that we get of those rings changes. So every year you might get the rings right edge on so that they almost disappear. You might get them tilted a little bit like they are now. You might get them tilted very, very far so that we get a really good view of them. Right now they're kind of halfway, and they're getting, the view of Saturn's rings is getting worse as the orbit of Saturn carries it into the area where we're going to see those rings right edge on. And they're really thin. They're thinner than a piece of paper is compared to its size. So when they're edge on, they're pretty much invisible. Here are some of Saturn's many, many moons. Most of them you can see in a decent telescope. You can see 3, 4, 5, maybe 6 of them, depending on the situation. Sometimes they'll disappear behind the planet or so on because they're in close. Titan is an interesting one. Titan is the brightest one and the second largest moon in the solar system. It's also the only moon with a significant atmosphere. Oh, the atmosphere doesn't really show up here, but it's covered with a methane smog. And so it's basically a planet on its own, except that it doesn't go around the sun, so we don't call it a planet, but it's pretty much planet-sized and a very interesting world. We think there's probably a liquid ocean of methane on the surface of Titan. So that's pretty cool. Well, in fact, we know that there are lakes because we've actually seen them from the Cassini spacecraft and the Huygens probe that parachuted down through the smog and took some pictures. Pretty fascinating spot. There's one more moon of Saturn that I like to talk about because it's probably going to be the most famous moon in the solar system soon. Enceladus is an icy moon. We don't get a good view here. That's too bad. Enceladus is an icy moon because it's mostly made of water. And of course, in space, minus 200 and some degrees, the outside layer of water is frozen ice as hard as rock. But under that, from the warm core of Enceladus, there's some heat that melts the ice. There's a global ocean under the ice of Enceladus. And actually, for those of you that are hitting the Pink Floyd show, there's a scene of Enceladus and the potential for little life living in that ocean. I believe that when the Europa Clipper spacecraft gets to Enceladus in a few years, it will basically sample the water from that ocean, not by going into it, but just by flying through. There are geysers on Enceladus. And so it'll fly through the spray from the geysers and see what's in the water. I think we'll find life there. That is my biggest, if I have to pick a place where we're going to find life in the solar system beyond Earth, it's Enceladus. Ulrich is asking, can you see Titan in binoculars? Yeah, you absolutely can. As long as it's sort of far enough away from the planets. Sometimes when it's swinging around in the front of the planet, here, we'll move over here a bit, it can be a little close in and lost in the glare, but as it orbits around, it gets quite far out on the side, so you can absolutely see it. And I think that with the bigger binoculars, you could probably also see the moon Rhea. It's quite bright. Actually, you know, a bunch of these would be like right at the limit of big binoculars, but Titan should be visible in binoculars quite easily. Good question. Oh, Hollis, your cat is watching with you. Wants to know if George is going to make an appearance. It's funny, when I was doing my tech rehearsal this afternoon, George came downstairs, and this is the first time I've sat at this desk for months, and so he was very curious, and he jumped up on my lap, and he was climbing all over me, and he was quite excited, but I haven't yet seen him come back down. He just had his food, so I'm not sure if we'll see him or not. I hope so. Let's see. Craig is asking about, will there be an opportunity to see an old school Zeiss projector show at some point? Interesting. So we do use the Zeiss projector sometimes during the Pink Floyd shows. And we also use it occasionally during Worlds of Ice. There are a few scenes there where, for whatever reason, the star scenes are not quite as impactful as I'd like, and so we turn on the extra stars there. We are talking about doing some Zeiss sky shows, doing basically an on-site version of Dome at Home, so that people could come and see this in the planetarium. And for that, we would use Marvin, our Zeiss projector, as well. Oh, Alan Dyer. Hey, how are you, Alan? Good to see you. Yes, it's a Worlds of Ice's Canadian show, and it is actually really, really good. It's distributed through the National Film Board, so you can actually see a bunch of the content online as well. But it works really, really well in the planetarium. And we'll talk about another Canadian planetarium show in just a little while. Okay, let's see. Okay, back to our September skies here. Saturn and the moon, like I say, that's the early evening highlight for me. Jupiter is rising. Now, Jupiter is the most observer-friendly planet that there is. It's the biggest planet in the solar system. It's got 4 bright moons that are visible in binoculars. It, in a telescope, shows all sorts of amazing detail with the cloud bands across it, occasionally the great red spot, And as the moons go back and forth, they will cast their shadows on the planet sometimes, and that sort of ballet of the moons going back and forth is different every night. It really is a beautiful planet, and because it's so big, it's easier to see detail on it. And of course, it's half as far away as Saturn. It's much closer, so we get the best view of Jupiter of all the planets. I would say it's really the old faithful of planets for observing. In binoculars, you can see four of the brightest moons, the Galilean moons that Galileo discovered back in 1609, 1610, I guess. And you can discover them on your own, just with household binoculars. Jupiter will get higher in the sky just because of the position that it's in our sky. So that means we will get better views of it here in Canada than we will of Saturn this year. And I plan to make the most of that. So I'm doing my planetary observing on Saturn right now, but it's kind of a warm-up for really getting some good pictures and some good viewing of Jupiter this year. So that's really going to be, I think, the highlight. Jupiter doesn't reach opposition for another month or so, so we actually are, if you want to get good views of it, you have to do what I've been doing the last couple of days and get up at 4 a.m. and find out if the sky is clear and then set up all your gear and things like that. It's a little daunting, and more than one morning I have looked outside and thought, oh, maybe not today, and I've gone back to sleep. That's unfortunate, but it's the way it is. Now, as the night, let's zoom out here. As the night goes on, everything rises higher. Jupiter is over in basically the edge of the fall constellations, moving over into the winter constellations. We've got Taurus, the bull, over here with the V-shaped Hyades star cluster, and the Pleiades, or the Seven Sisters, in that part of the sky. To me, that's the winter sky. But if we fast forward, we'll come back to our constellations in a minute, but if we fast forward to just before dawn, another planet puts in an appearance. Venus, that we have been watching for months in the evening sky, finally went around through the solar glare, disappeared, and has now reappeared in the morning sky. And if you want to get up around 6 a.m. or 6:30 or so is probably a decent time. Most of the other stars will have faded away, but Venus will still be up there. You'll be able to see that all month. And while it does move a little bit relative to the stars, it doesn't really move too much compared to our horizon at sunrise. The time of sunrise changes, and there's all these factors that are changing, but Venus will kind of be over there in the eastern sky before dawn pretty much the whole month. You will probably want to get out there and check it out fairly soon, because then you'll have a nice reference for a little bit later in the month. On the morning of the 10th and the 11th and the 12th, the moon moves past there. Nice thin crescent moon will appear kind of close to Venus. Not a very close approach, not close enough to put them both in binoculars, but still a reasonable view. And then, towards the end of the month, another planet pops up. Mercury pops up just above the eastern horizon. This will be a challenging observation for most people, unless you have a nice flat horizon and nice clear skies. Mercury does not get very high above the horizon this time around before it starts dropping back into the haze. It does get fairly bright though, so you can wait till, here we'll go to 6:45. That puts it up a little bit higher, and maybe even as the sun brightens the sky, Venus will be visible, and you can use that as a signpost to figure out where Mercury is. Binoculars will certainly help you track down Mercury, but that's a pretty reasonable morning observation. And as the sunrises are getting later and later, as we're getting away from summer, it's not really getting up too early anymore. So like even 7 a.m, you'll still be able to see Venus towards the end of September, and maybe even Mercury. Mars is around the backside of the sun, really not visible right now, and it's at its most distant anyway, so even if you could see it, there wouldn't be much to see. Mars is one of those planets that it's amazing for a few weeks every couple of years, and the rest of the time it's a real challenge to see too much on it. Venus is really, really bright, but it's not something that shows a lot of detail. In a telescope, about the only thing that you can hope to see is the shape of Venus. Right now, it's just come around the sun. It's a little bit of a crescent kind of phase, and that gives there we go. That's a nice thing. You can sometimes pick that up in powerful binoculars, but certainly in a small telescope, you'll start to notice the phases there. Okay, let me just check a couple of things here. Good. Mercury, the same thing in a telescope. About all you'll be able to see are the phases. And they change quite rapidly because Mercury whips around the sun in 88 days for a whole cycle. So to go through the couple of weeks that we can see it for, it really changes its phase quite quickly. Okay, I'm going to go back to sort of the middle of the month here, and we're just going to take a view back in the early evening because, I start with the planets because those are sometimes the changing special event kind of things, and they're nice and bright. You can see most of them from inside the city. But if you get out into a reasonably dark location, the stars, the constellations form the backdrop that we use to sort of make sense of the sky. And as I mentioned, there's all the different seasonal constellations. The ones that we're always familiar with are the circumpolar constellations, the ones that circle the pole star, Polaris, and those we've been talking about since the very first Dome at Home show. The Big Dipper over here, very low in the northwest. I can't even see it over my neighbor's house because it's pretty low. And the rest of these stars that make up, depending on who you ask, a Great Bear, or to me it actually looks more like a fisher, which is kind of like a weasel-like animal, and that fits in more with the Anishinaabe constellation version of these stars rather than the old Greek and Roman ones. I don't think that whoever named this the Great Bear had ever seen a bear when it comes right down to it. It just doesn't, a big long tail here and really long legs, and I don't know, anyway. But the Big Dipper, a useful signpost. The two pointer stars in the bowl of the Big Dipper, the ones that are farthest from the handle, they point up and they reach to the pole star, Polaris. That star stays exactly above the north part of the horizon and stays stationary, and the entire sky appears to rotate around it. The Little Dipper is hard to see from inside the city. It's famous all out of proportion to what it looks like. The only reason people even know about it is because Polaris is in it, I think. But it's got really faint stars that I can't see from my backyard in suburbia. I can see these two at the end. They're bright enough. But you get into a darker sky, and certainly that becomes visible. There's a bunch of other circumpolar constellations. I'm not going to go into all of them here, but one of the most useful ones is Cassiopeia, the queen. Cassiopeia, this is a queen sitting on her throne, or the letter W, or a lightning bolt, or the number 3. It kind of depends on how you look at it. But Cassiopeia, nice bright stars, all fairly compact. It really sort of stands out in the sky. And it's kind of, not exactly, but kind of opposite the Big Dipper in the sky with the North Star in the middle. So when the Big Dipper is down low, like it is right now, and I can't see it because of the neighbor's house, Cassiopeia will be up higher. And at least I'll be able to, there's no pointer stars that really point back to Polaris exactly, but at least I can sort of eyeball it and figure out, okay, that's kind of north. Cassiopeia is really useful. We'll come back to her a little bit later to find a few of the other things that are interesting in the sky. Dominating the south, it's still August. It's still astronomically summer, and we have the summer stars have not faded away. So even though it's getting pretty cold at night, and we're getting, at least here in Manitoba, we've had a couple of days where there's pretty chilly dew on the all over things in the morning. The summer triangle is still dominating the sky in the early evening. 3 bright stars that look like a big slice of pizza. At least, if they slice your pizza classically in the triangles. The 3 stars, each one is part of a different constellation. The brightest one is Vega. It's almost right overhead for us here in Winnipeg as it's getting dark. and it's the brightest star in the evening sky. It will be the first star you see at night. And it's part of Lyra the Harp over here, which is this tiny little constellation that to me doesn't look like much of anything. But Vega really stands out. Down at the bottom here, the triangle pointy end is a star called Altair, and it's got a couple of stars, one on either side, that makes it stand out. So that's sort of how you know you got Altair. These stars are fairly bright. It's part of Aquila the Eagle. Aquila is a constellation that doesn't look at all like what it's named after. It's supposed to be an eagle carrying a person. It kind of looks more like maybe a stingray with a long tail. And then the other star in the summer triangle, the faintest of the three, is Deneb. And Deneb is in a constellation that actually kind of looks like what it's named after. This is Cygnus the swan, and Deneb is the tail feathers, and then the body is here with the long neck, sort of stretched out. Here's the beak, and then its two wings are outstretched. It's flying overhead, flying down the Milky Way in the sky. And so Cygnus is pretty easy to spot as well. Those three stars make up the summer triangle, but you will see them in the early evening until November, maybe even later. Because right now, the seasonal stars are slowly advancing, each month, a little bit each day, so that they, they basically maintain the seasonal connection. But the sunset is also setting earlier each night. So if you go out just after dark each night, you're actually going to see kind of the same sky for a little while. It's almost like time stands still for this time of the year. Now, if you went out at the same clock time each night, you would actually see that the stars are progressing in their seasonal cycles as you would expect. But it's because of that being counteracted by the earlier sunsets that it feels like summer just doesn't want to go away. And I am totally fine with that. The summer stars are great. The Milky Way goes right through them. There's Cassiopeia over there, and Cassiopeia is also in the Milky Way, and it arcs all the way across, right through Cygnus, right down past Aquila, and then down into the southern sky. The brightest part of the Milky Way is sort of right at or below our southern horizon from here in Manitoba, so we don't get the best view of the Milky Way that we could. Again, our friends in Texas, or if you ever travel even down to the middle of the continental United States or anywhere south, you get a much better view of the core of our Milky Way. The center of our Milky Way is, apparently right in behind my head, right in that area. Okay, the summer stars are going to be visible, but it is fall, and fall is probably the most difficult season to go constellation hunting, especially if you're relatively new at it. There's not a lot of bright stars. There's not a lot of constellations that really jump out at you. They look pretty easy when they've got nice red lines connecting them on the screen, but when it comes down to actually seeing them in the sky, it can get pretty tough. Luckily, there is one constellation that stands out, at least part of it does. It's called the Great Square of Pegasus, and it's 4 stars, almost all the same brightness, and almost a perfect square in the sky. The human mind likes to see patterns and things like that, and so this really jumps out at you when you're looking at it. It's kind of like a diamond right now because it's standing up on its corner. This is also a slice of pizza if they slice your pizza in the square, more pieces per pie kind of method. So you can tell I haven't had dinner. Pegasus is from the Greek myth. It's the flying horse, and these are supposed to be the wings, and its neck stretches off over here, and that's the tip of its nose, so it's an upside-down flying horse, and these are its front legs, and its back end is not present in the picture, because attached to its back end is another constellation, Andromeda. This is Andromeda here, this chain of stars. Andromeda is from the Greek myth, the princess chained to the rock, sacrificed to Cetus the sea monster, and her parents, Queen Cassiopeia and King Cepheus, have to do this to prevent their kingdom from being destroyed. But luckily, Pegasus flies by with Perseus the hero, who happens to be holding the head of the Medusa, and he saves the day. And if you can watch Clash of the Titans on Netflix and get the whole myth. All of those are constellations. Cassiopeia is up here, Andromeda down here. This is Perseus right next door. Cepheus doesn't look like much, quite faint, but is also present in the sky. That's what these myths are for. They're not really just adventure stories. They're not just the pre-electrical version of Netflix, although they were that too. They were a way for people to pass on the knowledge of the sky and which constellations fit together and belong together. And I think that there's this one unifying myth for these fall constellations, partly because there isn't a lot of standalone bright constellations that are there. Things like Orion in the winter or something like that, he gets his own sort of story because he's big and bright and everybody can find him. But the fall constellations, a lot of them are kind of faint. And so I think that's why there's this one big, like I say, unifying myth that brings them all together. There's lots of things we can look at in the fall sky. We've got the Milky Way area. We've got the transition to the winter sky. In these fainter areas, though, in the non-Milky Way part, there are piles and piles of galaxies. So if you have a telescope, it's definitely galaxy season. Not quite as good as the spring galaxy season, but still lots of cool ones. And the brightest galaxy in the sky is a fall object. So I'm going to show you how to find that one. It's called the Andromeda Galaxy. It is 2.5 million kilometers away and 2.5 million light years away. Oh my gosh, that was a little off. So the light that reaches us tonight has been traveling for 2.5 million years. That's a pretty long time. It's part of Andromeda, but I never use Andromeda to find it. I actually use Cassiopeia. Cassiopeia is the letter W, and one side looks like it's kind of squished, but the other side looks like a pretty respectable, almost right angle W kind of shape, or a V shape. If you think of that as an arrowhead, it points down this way, and it points to Andromeda, but there's 3 stars in a line here. And right beside that, we're just going to use the Stellarium here to zoom in a little bit. Right beside the line of 3 stars is the Andromeda Galaxy. It looks to the unaided eye from a dark location, when there's no moon out, you can see it with just your eyes. It looks like a little oval piece of Milky Way, just sort of all by itself there. It's the farthest thing that you can see with the human eye, unless you have very exceptional eyesight. It's the farthest thing you can reliably see with your eyes. In a pair of binoculars, you can see it even from inside the city. And in a telescope, it becomes pretty amazing. Once you start taking pictures of it, we start to see the details of what it is. It is a spiral galaxy much like our own, probably about twice as big, actually. A big core of stars, spiral arms radiating out. We're seeing it almost edge on. So instead of the big spiral that we sort of imagine, we're seeing it just from the edge. It has a couple of satellite galaxies that go around. Actually, there's about a dozen of them, but these satellite galaxies are visible. These 2 are visible in a small telescope. It really is an amazing object to see. And it is literally the farthest thing that you can see. And so when you look at it, those little photons of light were emitted from a star in another galaxy and have traveled for 2.5 million years and have avoided being absorbed by interstellar dust or being deflected by the gravity of an object in the galaxy or in our galaxy, and have made it all the way to Earth and have penetrated through the atmosphere, and with luck they don't get blocked out by clouds or whatever, and then that piece of energy winds up inside your head. That's one of the magic things about astronomy. There's a real connection to these amazing, great, and distant things. Now, as you know, I can talk forever. Let's see. Linda, nice to see you. Yeah, very cool. Greek islands, yes. So the Greek islands are a little bit farther south than we are, and so you will get a little bit better view of the parts of the sky in the south. But it's not a huge change. I'm not sure what the latitude there is exactly, but it will be it'll be a little bit different at the end of September. Drop me an email, and I'll send you a little bit of stuff that I have to take a look and maybe help you out finding some stuff in the Greek Isles. And let's see. Ulrich is asking, do we actually know for sure if the Andromeda Galaxy still exists? Well, it depends on what you mean for sure. Galaxies live for billions of years, we think, and so that the odds that the Andromeda Galaxy suddenly has, imploded or whatever, or all the stars have burnt out in our lifetimes is pretty remote. But we actually don't know, because all we can know is the light that gets here. So we only know that 2.5 million years ago, this is what it looked like. There could be major changes. There could be things like a supernova explosion, or those other galaxies are eventually merging into the Andromeda Galaxy. I guess we do know that it is still existing because the gravitational effect is still there. It's actually approaching us, and in some number of billion years, it and our Milky Way will actually pass through each other and probably merge. But yeah, we're looking back in time when we're astronomers, and there's no such thing as now in the grand scheme of things. There's just what we can see, and that's close enough to now for us living on the Earth. But even just talking to the robot helicopter on Mars, that's a 20-30 minute journey by radio, and that's why it has to be able to fly around itself without human intervention. Okay, I've gone on a little long, but it is now time for...
Cool Space Stuff!
You didn't think we weren't going to have cool space stuff, right? Let me get our thing queued up here, sorry. There we go. So happy birthday, James Webb Space Telescope. I mean, that was last month, but the last time we did a show, I think, was for the launch of the James Webb Space Telescope. So it's been a while. This is the image that they released for the 1-year anniversary of operations. And of course, James Webb Space Telescope, as I predicted, stuff is coming out of that telescope so fast, we just cannot keep up with the images and the discoveries and the new ideas for science that's coming out of it. It's going to be one of those things that it will take decades to really sort out the amazing images that it's sending back. This is a star cloud around a star called Rho Ophiuchi, which is in the summer sky in the summer Milky Way, and just a beautiful, beautiful image. Robots to the moon race that we had going on just the other day. We were asked if we were going to cover that. Yes. The Indian Space Agency launched a moon probe a few years back called Chandrayaan-2, and it was trying to land and had some problems and crashed. So they launched Chandrayaan-3 just recently. And then after they had already set their launch date and so on, from out of nowhere, Russia said, oh yeah, we're launching our own moon probe, and we're going to launch it before yours, and it's going to get there first, ha ha ha. Which was, I mean, I don't follow the Russian space program as closely anymore, but I knew they had plans to do it, but the launch dates seemed to be set very, very quickly. So suddenly there was this competition. And Luna 25 was also going to land, and both of them were targeting the south pole of the moon, which has never been done before. Nothing's landed there. And that's where all the ice is in the craters that are sheltered from the sun. So that's where you want to build your moon base, because there's ice with water and hydrogen and oxygen, which is air and rocket fuel, basically. Everything you need is sort of available there. So Luna 25 got to the moon first, got into orbits, and as it was changing its orbit, something went wrong, and it crashed. So Luna 25 did not land successfully, which is too bad. The Luna program dates back to the 60s, and I mean, that's why it's Luna 25. And they've had a whole bunch of failures, but also a whole bunch of really successful probes. Big rovers that drive around on the moon autonomously, and just lots of really good stuff back in the day. The Indian space probe, and this is just to give you a sense of scale. This is Luna 25 before it's loaded on the rocket. So we're not talking about gigantic spacecraft, but relatively relatively compact. The Indian Space Research Organization launched Chandrayaan-3, and it was a lander, and on the lander is a tiny little rover, it's like a toaster, pretty much. And the excitement of that thing landing, I watched some of the footage, and people were they were over the moon with excitement because they'd had a couple failures on it before. Their space program is really pushing the technology of the country and so on, and really helping develop a lot of the society. And this success was just really, really great. This is a shot of the lander from the rover, which has already driven down that little ramp on the right-hand side and gone out a few feet and then turned around and taken pictures. This is that standard sort of proof of life photo of, yep, we are on the moon and here we are. So congratulations to the Indian Space Research Organization for a job well done. I'm looking forward to seeing what comes from that. There's still the orbiter in orbit around the moon, which has taken some great pictures too. And in fact, they took pictures of some of the Apollo landing sites, which was kind of cool. So big news on the moon. This is another thing that's kind of we've been following on Dome at Home. The X Prize was the plan to develop a spacecraft for human passengers that would be inexpensive, and Spaceship One was one of the one that won that, and that got developed into Virgin Galactic's spaceship craft. This is carried up by an airplane, then dropped, and then it rockets up into not into orbit, but up into space, and you get 4 or 5 minutes of weightlessness at the upper edge of space, and then you come back down and land on the runway. It's still a fairly expensive ticket. I think it's $300,000 or $400,000 it's gone up to now that they're actually doing them. There's a couple of folks in Winnipeg that booked their seat long time ago, so they're on the waiting list and they're basically waiting. But these flights are now going every few weeks, and so hopefully we'll see a bunch of those going. And eventually the price is going to come down, right? Eventually we're going to be able to just go to Vegas and buy a ticket for one of these and just go that afternoon, right? I hope. The Chinese space station, wow. Since the last time we talked, it's about 3 times bigger than it was. It's pretty much almost complete now. They built the space station in about little over 2 years, as opposed to the 10 or 12 years that the ISS, International Space Station, took. Of course, it's not as big, but it's quite capable. And they're doing something interesting. They're basically building their own Hubble Space Telescope kind of thing, but instead of orbiting it separately, they're sticking it on their space station so that it's available to be maintained and all that stuff. Now, there's some pros and cons with that. I mean, every time somebody, is on the jogger in the space station is going to make some vibrations. So it'll be interesting to see how it works out. But they're definitely going their own way in terms of their space program. And so that is up and going. And of course, the International Space Station, right now, a crew of 11 from 5 different countries. And the SpaceX rocket just took up the crew replacement. Those folks in the darker shirts in the back just got there, and then some of the folks will be going home in a few weeks, I guess, as they rotate through the crews. But the space station is still up there, still doing all of its very cool stuff. There's been some discussion about what's going to happen. The Russians have indicated they're pulling out of the space station after 2024, although they didn't say how long after 2024. So we'll have to see. I'm sure that in NASA and the Canadian Space Agency and all the international partners, everybody is looking at contingency plans for, well, what do we do if Russia's, modules are disconnected and go elsewhere? So anyway, it'll be interesting to see. I'm not sure that Russia will actually bother pulling out of the space station. It's so expensive to go and do their own thing. I think it was more sort of a little bit of a reaction to not being as friendly as they once were. But we'll have to see what happens with that. Still visible in the sky. You can still catch it going overhead. And always nice to go. All right. That's our space news section. Oh, no, sorry. almost forgot, the Artemis crew, Artemis 2, Jeremy Hansen, the Canadian guy there just above my head. They have begun their training. They have seen the spacecraft that will carry them to the moon. It's being constructed now. They're still looking at flights sometime in 2024. So we still don't have a date, but we're following that. And of course, it's really exciting, the idea that a Canadian will go on a lunar flight, not to land this particular time, but to go all the way around the moon and back. And so you can bet that that will be a huge event for all of us here in Canada. Our show next month will be Thursday, September 28th, and we're going to feature the October 14th solar eclipse. It's, as I mentioned, an annular eclipse on a path from, let's see, Oregon through Texas and down into Central and South America. But for us here, it's about a 50% partial eclipse. We'll talk all about how you can observe it, what you need for filters, how you can observe it online, and we'll talk a little bit more about our telescope event that we're going to be hosting. The Planetarium and the Royal Astronomical Society of Canada's Winnipeg Centre, the local astronomy club, will be out with telescopes to be able to watch that live. That's always fun. It's great to watch a stream from somewhere, which is, amazing. We couldn't do that, a couple decades ago, but to be able to see it through a telescope yourself with your own eyes is also pretty magical. So we're going to make that happen for the October 14th solar eclipse. I'd like to thank everybody that helped put the show together, which basically is all of our folks at the museum, everyone from promotions to our friend Mike, who does the cool space stuff announcements, and he's recorded a few more. I'll have them for next episode, so there'll be more of Mike's voice in the show, which is always nice. Our opening theme from Sebastian and Genevieve, always great to hear that. As I was practicing, it was amazing, hearing that music again. I was like, wow, that felt like it was a long time ago. And it was, but it won't be so long before our next show. So thank you all for joining us. It's been really wonderful to be back with you all. I'll go through the chat and answer any questions that I didn't get to live, but you can always reach us through the various social media or email methods. You can catch us there. Thanks again for having me in your Thursday plans. And now I'm heading off to the museum to be at the Pink Floyd shows. The first one's already going, but the 9:30 show is the one I'll be at. So if anybody happens to already have tickets to that, it's sold out, unfortunately. But let's say hi there. Thanks again. Have a great evening, and we'll see you soon.